These are exponent rules you need to know. Multiply with the same base, you add their exponents. In this example, if you have division, you subtract their exponents. If the two exponents are multiplied, or sorry, a to the x to the y, you multiply. A to the negative x, you put it in the denominator. If it's a to the negative x in the denominator, you can bring it up. And then this x exponent goes to both terms. And I know I've already talked about these special products. And then let's make sure we're good with this e to the x. So if I have e to the x and e to the 2x, since the base is the same, you add the exponents. Since the base is the same of these, you subtract their exponents. And then here, you're going to multiply. So let's just go through these. This is one that's a common mistake, so that's why I'm going to go through this. So x times root x. I'm just going to go slow. So that's like saying x times x to the 1/2 minus x times, and then 1 over 2 root x. So you add these exponents, so that gives you x to the 3/2. And then this is x to the 1, subtract off x to the 1/2, so I'll get a minus 1/2 root x. And it doesn't matter to me how you write this. You could write this as, root x over 2. Doesn't matter. Okay, so let's look at this one. So if I distribute this, you're multiplying, so you're going to make this, since they have the same base, you're adding the exponents. And then this one times this one, let's just go slow, e to the 3x over e to the x. I'm going to subtract those exponents. So I'll have 3x minus x, so that'll give me e to the 2x. And you know you would never join those together. This one here, we're going to use that special product. So I'm just going to go slow. 3 over e to the 2t squared plus 2 times 3 over e to the 2t, e to the 2t, and then plus e to the 2t squared. So you know you're going to square each of these terms. So I get 9. And when I square this, I'm actually multiplying those terms. So I get e to the 4t. And then when I multiply all these together, you can see that these e to the 2t's cancel. And so I'm just left with 6. And then for this last term, get it over here, I'm going to multiply these exponents. So I get a plus e to the 4t. Let's do that same special product with this one. So I'll have e to the 2x squared minus 2 times e to the 2x, 3e to the negative 2x, and then plus this last term squared. So multiplying the 2x times the 2, that gives me e to the 4x. And then here you can see it. When I multiply e to the 2x times e to the negative 2x, that gives me e to the 0 because I add those exponents. So that gives me minus 6. And then here I square each of these terms. So 3 squared you know is 9. And then I'm going to square this, so that means multiplying. So I get e to the negative 4x. All right, so these are important identities. You need to know all of these right away. We'll be introducing these two in about a month or so, but make sure you really, really know these identities. Conjugate. So lots of times it's used when there's radicals, which means square roots. So root x minus 1, the conjugate of that is root x plus 1. So you just change the subtraction to addition. So if I had this expression and I want to multiply by the conjugate, I multiply top and bottom by the same thing. And then on the numerator, I'm not going to multiply it out. But on the denominator, hopefully you see, this is kind of like saying a minus b times a plus b, right? Where the a is root x and the b is 1. And so difference of squares, that means this root x squared, which is x, outside, inside terms cancel, and I'm left with negative 1 times 1, that gives me negative 1. And that would be the answer. All right, so let's try this one. Just giving you different places to, or different problems to practice the conjugate. So here, I would change this sign, not that one, but this one. So I'd have x minus 4 minus root x, and then root x minus 4 minus root x. And then again, I'm going to recognize that this here in the numerator is difference of squares. So this times this, that's going to give me an x minus 4, right? Because the two radicals cancel out. The outside and the inside terms would cancel. And then what I'd be left with would be the last terms. Positive root x times negative root x. That would give me a negative x. And then in the denominator, and I'm not going to multiply it out, I'd get 4 times root x minus 4 minus root x. Simplifying that numerator, I can see these two x terms go away. So I get a negative 4 over 4. Oh, and it's a good thing I did not multiply that denominator out, because I can see these 4's cancel. Remember, only cancel when you have multiplication between terms. So if I cancel the 4's, in the numerator, I'm left with a negative 1, right? Negative 1. And in the denominator, I've got this root x minus 4 minus this root x. All right, last one of this, or the last one with this conjugate. So let's do it. So I'm going to multiply numerator and denominator by root x plus h plus root x, and then root x plus h plus root x. Remember, you change the sign of this right there, right? Okay, so in the numerator, I'm not going to multiply that out. I'm just going to carry this along. Plus root x. And in the denominator, I'm identifying that this is the difference of squares, right? This is like the a minus b times the a plus b. So this gives me a squared, where that's the a, so that's x plus h. Root x plus h times root x plus h gives me x plus h. Plus, outside, inside terms go to cancel out. So I get negative root x times a positive root x, and that gives me, whoops, a negative root x. Negative x. Negative root x times positive root x gives me just an x. So let's simplify. And again, I'm going to encourage you not to multiply things out, because you're looking for canceling. Oh, will you look at that? So these h's cancel, so I just am left with root x plus h plus root x, and that's the answer.